Good morning, everyone. Welcome there to another session of mechanics. Like I told you, mechanics changed from Monday, Friday. Someone else will be taking you on in trigonometry on Monday. And Wednesday will be our statistics. Also next Wednesday, remember to come with a book as I'll take you through the ogive curve. Hope you've tried out some numbers, like I said, to have a better picture of what the histogram looks like. I hope either next week or the coming week after that, we shall have a test in paper 2. It will be having both mechanics and stats, so people should ready themselves for that test. So today we want to look at another Atwood's machine. Another Atwood machine. I do not remember the case, but for this one, we can have.
Teacher.
Yes, please.
Do you have a question about police?
Please go ahead, ask.
It is a diagram showing two pulleys of masses 8 kilograms and 12 kilograms. But this diagram has one fixed pulley, then two movable pulleys. But on these two movable pulleys, each has 2 kilograms attached on it.
I've got the question.
Which
it looks like
is
this.
Confusing.
Like this. Like that. Like that. The masses are here.
Yes.
Is that it? Now, it is the definition. You cannot do that right now. Let me first finish this concept. It will guide you through that.
Okay.
It means you're solving. That is good. Okay. So, guys, the definition is going to be, if you have a fixed pulley, and this fixed pulley has a mass of M1 kilograms, and on the other side, it has a movable pulley, which is being pulled upwards, and has masses M1 and M2. I mean, this is M2, M3. So this would be M3G. This would be M2G. This will have a force of weight, M1G. Now this pulley, a string moves from M1, passes over a fixed pulley. The fixed pulley can be rotating in the acceleration A1. Then it comes and is attached to the axial of the movable pulley, which is rotating at A2. But the string stops here. When that string stops there, it means this string has a tension T1. Then this other string passing over the movable pulley will have a different tension, which tension I can call T2. Now, if the movable pulley is heavy, then it will have mass M of 4 kgs, and it will have a weight here. Its weight will be, let me put it here, M of 4 G. That is if it is heavy. But if they tell you it is a light movable pulley, then M4 is 0. And for that regard, if M4 is 0, it means the movable pulley will not have any weight, as I'll show you in the derivations. Now, if the system is released, and perhaps the entire system this way is going down, then M3 is going down also, as M1 is rising upwards. Then this M1 will go up, this M2 will go up. So this pulley is going down because of the direction. This one is rotating this way. Also, this one is rotating this way. So the resultant force on M1 shall be M1 kgs. We shall have tension T1 minus M1 Vg is equal to M1 rotating with A1. Then after we have confirmed that, come to M2 and A2. That is where the new definition is. The related acceleration of those two will be in the form that, look at this movable pulley. Where is it going, this one? It is going down, okay? If it is going down, look at the mass which is going down. The mass also which is going down on the movable pulley is M3G. So this M3 has a force, M3G taking it downwards. It is in the same direction as this one. Now, if it is in the same direction, it becomes A2. Its acceleration becomes A2 plus A1. Why? Because the pulley is moving it down, even this mass is moving down. So it's moving in the same direction as the direction of the movable pulley. So the resultant is the sum of the two accelerations of the rotating pulleys. While for this one, which is going up, it is its movement upwards is opposing the motion of the movable pulley. The movable pulley is going down, for it it's going where? Up. So the resultant acceleration on it shall be, the resultant acceleration shall be A2 minus A1. So it is trying to go up to oppose motion of the direction of this A1. That's why for this one we attach a negative, for this one we add them together, because if you look at these arrows, both of them are rotating in the same what? Direction. While for this one, as it is going up, this one is coming what? Down. So the resultant acceleration is a negative for A1 and a positive for A2. So it becomes A2 minus A1. So that is the definition here. So the most important thing about this Atwood machine is that the mass which is moving in the same direction as the movable pulley, its acceleration is always just the sum of the two accelerations. Then the mass which is moving in the opposite direction as the movable pulley, its acceleration is a subtraction of the two accelerations, but with the leading acceleration being the acceleration of the movable pulley and the laid-off acceleration being the acceleration of the fixed pulley. Now, to write the resultant, I needed to first get those accelerations. The resultant acting on M2 kgs, we shall have tension T2 minus M2G is equal to M2, which M2 is moving with, A2 minus A1. Then when you come to M3, M3, because it is going down, it is M3, the weight, that is overcoming tension T2 to give us M3 times A3 plus A1. Now, my friend who had a question, your question is ideally is in this same format, but just that this side, it has another movable pulley. So you just use the principle. Assume the fixed pulley has A1, then these movable pulleys can have A2 and A3. Then you design the equations. If, I said if the movable pulley is heavy, then it has a mass M4. So if it is heavy, let me extract it out so that I don't congest the diagram. This is the movable pulley with a string here taking it to T1. Then this side it has T2 and T2. If it's heavy, it will have here M4G. But as it is moving, it will move like any other body. That's why I've not attached here M3 and M2. So it moves like the way you see M1 is moving about the fixed pulley. So it will move with an acceleration A1. It moves with acceleration A1, up or down. So because it is moving down, T2 and another T2 plus its weight, they are the forces that take it down and they overcome T1 to realize M4 times the acceleration it moves with, which is for the fixed pulley, A1. So it is from here that the formula becomes 2T2 plus M4G minus T1 is equal to M4A1. So this was equation 1. This is equation 2. This is equation 3. Then we have equation what? 4. But if M4 is a light pulley, then M4 is equal to what? To 0. So if M4 is 0, it means 2T2 plus 0 minus T1 is equal to 0. Therefore, always 2T2 is equal to T1. That is occurring if and only if they have told you the pulley, which is light, which is movable, is light. So M4 would be what? 0. So those are the basic definitions on this definition and the basic equations we require. Of course, if I solve this as proofs in terms of simplifying, I might bore the whole of your day. So what we are going to do straight away, we shall use examples to show you how to solve. Unless someone has a question on the definitions. Yes, please. Go ahead.
Teacher, when you are getting the equation for M3, why did you say that the M3G minus the T2 is okay? For the acceleration, you said A3 plus A1.
A2 plus A1. This one, eh?
But here you wrote A3 plus.
Oh, thank you so much. Nice eyes. So it is A2. Guys, that is A2 plus A1. Eh?
And also for the M2 mass. Why did you say A2 minus A1?
Okay. Look here. The fixed pulley is rotating in this direction. Not so. The movable pulley is rotating in this direction. This has A1, this has A2. I'm looking at mass M2, not so. Now, M2G, it is going up by what force? T2 is the one taking it up, overcoming M2G. But the resultant acceleration will be the acceleration due to this direct pulley making it move, which is A2. Because A2 is going down, yet this one is going up, this one is rising up. So this M2 appears to oppose the motion due to the fixed pulley. So in opposition, acceleration is a vector. So it is in this, here it is following the direction of this pulley, here it's opposing the direction of this pulley. So to get the entire acceleration of the entire system, we need the acceleration of the whole system. yeah, becomes the positive of A2 plus a negative of A1 in vector form. When you simplify, you get A2 minus A1. That is why I've said, always, for those of us who want to cram, and you feel like for you, you don't want to waste time of understanding these equations, these definitions. The acceleration which is in the same direction, the pulley which rotates in the same direction, I mean the acceleration which is in the same direction as the movable pulley, or the string or the mass whose direction is the same as the direction of the movable pulley, because this M3 is going down just like the movable pulley is going down. This is the movable pulley. So this M3 is in the same direction as the movable pulley, going down. So if those two are going down, then the one going down, its resultant acceleration is the sum of the two accelerations. While if the movable pulley is going down and the other mass is rising up, then the resultant acceleration of that mass will be the subtraction of those two accelerations. Is that a little bit more clear? I trust when you look at examples, we shall have it better interpreted. So download that, then we look at an example. So we have a number here. Having 3. This one will have 3 G newtons. This one will have 6 G newtons. This one will have 2 G newtons. This one will have a tension T1. Tension T1. This one will have tension T2. Tension T3. And they have said A is a light pulley. And they have said pulley A descends with an acceleration A1. So if it descends with an acceleration A1, it means this is A1. This one is rotating with A2 to rotate going this way by common sense. But the system here is going down. Here the system here is going what? Up. Then the 6 here is going where? Down. Then this one is rising what? up. Now the acceleration, Elizabeth Magala, what's the acceleration on the 2 kilogram mass if this system is going down as you see it? Elizabeth, give me the acceleration on the 2 kilogram mass. As another person prepares to give me the one on the 6 kg mass. Elizabeth? Okay, Mawanda A class. Mawanda A class, give me the acceleration on the 2 kilogram mass. Guys, look here. This movable pulley. Mawanda, when I asked you for the equation, you decided to block the network. We are back. Let's have our sketch again. I was saying we have a pulley system having here a weight of 3G. It is attached to a movable pulley on the other side. This one has 2G. This one has 6G. This has tension T2. This has tension T2. This has tension T1. This has tension T1. It was rotating with A1 as this one goes down. This one is rotating this way with A2. So I was asking someone to give me the acceleration for the 2 kilogram mass and the acceleration for the 6 kg mass. By random, can someone give me the acceleration on the 6 kg? Because this is 6 kgs. This is 2 kgs. And this is 3 kgs. Someone give me the acceleration of the 6 kg mass. The 6 is going down. The pulley is rotating this way. But this pulley, remember, is also going where? Down. So what is the resultant acceleration here on the 6?
A2 plus A1.
It is A2 plus
A1.
A2 plus A1. Good. Then can someone else give me the one for the 2 kg mass? Where is it moving? Is it moving up or down? Of course, we have seen it is going where?
It was
Up
moving
by common sense. This one is going where? Down. This system, the whole of it is going where? Down. As this one is going where? Up. What is the acceleration here? Zoom user.
A2 minus A1.
A2.
A2 minus A1.
Very good. So with that, let us now try to solve and design the equations. So we shall have 6G minus T2 is equal to 6 of A2 plus A1. Mawanda class just disappeared when I asked him to the answer. Then T2 overcomes 2G to give us 2 of A2 minus A1. Then the 3 kg, T1 is taking it up, minus 3G is equal to 3A1. Now they say the pulley A, this is pulley A. Pulley A was light. Because it was light, I told you if it is light, 2T2 is minus T1, the resultant force there is 0. Therefore, 2T2 is always equal to T1. And what does that mean? Those of us who want to cram, you can even use this. If this is T1, and this is T2, and also this is T2, then it acts as if it is in what we call limiting equilibrium. So sum of upward forces is equal to sum of downward what? Forces. So you can end up with this equation. 3, equation 2, equation. No, this is equation 4. This is 3. This is 2.
Then I get minus A1.
How did I get? How I got
Minus
this?
A1.
This one, eh? This one, eh?
Yes.
Yeah? It is because a 2 kilogram mass is moving up, yet the movable pool is moving where? Down. The movable pool is moving down with an acceleration A1. So this 2 kilogram mass appears to oppose the direction of motion of the acceleration A1. So to get the resultant of the accelerations, you will have this one, which is directly taking it up, which is A2, overcoming A1. So it becomes A2 minus A1. While A2, because the 6 is going down and the A2 is going down, even this string is going downwards, even this one is going downwards, then the resultant of acceleration on the 6 becomes A1 plus A2. I thought I'd finalized that one before. Now, solving simultaneously. First of all, I can add Roman 1 to Roman 2. Roman 1 is 6g minus T2 is equal to 6 into A2 plus A1. Then T2 is subtracting off 2g to give us 2 of A2 minus A1. When I add these 2, yeah, I will have T2 a negative plus T2, you get 0. While 6g minus 2g, you get what? 4g. Then I'll get 8 A2. Then this minus that, I'll get minus 4A1. When I divide everything by 4, I'll get g is equal to 2A2 minus A1. Let me call this a new equation star. Now, look here. We have T1 minus 3g is equal to 3A1. This is from equation 3. But we have said 2T2 is equal to T1. So drop it there. We shall have 2T2 minus 3g is equal to 3A1. If I call this equation star 2, then I can add star 2.
Excuse me, sir.
Yes, please.
Teacher, please. You are very fast.
Where am I first?
Excuse me, sir.
Yes, please. Please, if you see that I've left you
Simultaneously there.
when I'm solving small, yeah, when I leave you, please you ask. Eh? Don't just say that I'm very fast. When you say I'm fast, when you don't ask, it doesn't help. Okay? Now let's go back. Where exactly do you want me to take you? Where do you want me to
Supposed to be
review?
minus 4A1. I mean, it's supposed to be
Solving the simultaneous equation.
Okay, let us solve again. Look here carefully. I am adding Roman 1 to Roman 2, which is this one plus this one. When I add, I will eliminate this one. I will eliminate this one with this one. Because this is negative T2, add it to positive T what? Maybe you want me to write a 0. Is that okay? Now, when I add the 6g to negative 2g, I get 6 minus 2g, confirming a 4. Is that one okay? Those ones we are not seeing. Is that okay? Please respond.
yes, teacher.
Are we together now? Are we still together?
Yes.
Okay.
Yes.
Now come on the right-hand side. This 6A2, I am adding it to 2A2. Are we still together?
Yes.
I get 8A2. Do we agree?
It was meant to be plus 4A1.
Yeah?
It was meant to be plus 4A1.
Where is the A1?
No, as in, or as you continue, but it plus 4A1. Because if you had to open the brackets for
Thank you. Oh, now I know why people raised this. Okay. Now I know why people were complaining. Okay. Thank you for that. So this is 6A1 minus A2A1. Okay. So this becomes a what? A plus. Is that where the biggest problem came from?
Yes.
Okay. Sorry, guys. I'm sorry. Okay. So are we now comfortable with star?
Yes, sir.
Now, can I proceed to the second equation? This one I think is okay. This one is fine. Because I've got T2, T2, and I've dropped it here. Right? Is that fine?
yes.
Yes.
Okay, now, pay attention to this next step. The biggest problem with these numbers is not getting these equations, but simultaneous solving of senior 2 is the problem. Elimination, substitution, that's where trouble is, algebra. But the equations, everyone can get them. But solving them, trouble. Now, I want to eliminate T2. What I can do, I can add this star plus twice of Roman 1, which will become 2T2 minus 3G is equal to 3A1, which I'm using here. Then I come and multiply the whole of Roman 1 by 2. Can we multiply? What do we get? 12G minus 2T2 is equal to 12 brackets A2 a plus A1. Guys, can you see that?
No.
Why are we multiplying it by 2?
Guys, it is simultaneous solving. Remember, in simultaneous equations, when you want to eliminate something, if they do not have the same coefficient, you multiply by a factor, which makes it have the same what? Coefficient. That is senior 2 work. Do you still remember? Yes, it is what I'm doing, guys. So when I multiply the whole of this one, guys, by 2, this is our equation 1, remember. I come up with the 12 here, 2T2 here, and 12 there. Is it now fine? Someone there said, no. A gentleman, who was it? I don't know whether he's okay now. There's a gentleman who had said, no. Are you fine now? Mr. No. And I don't know your name. Was it Munidwa? Munidwa, you are the one, eh?
Yes, sir.
You're fine now?
Yes.
Okay, can I proceed? Let us proceed by addition so that we eliminate 2T2. I want to eliminate this one and this one, which is a negative. That is why I'm adding. Because in simultaneous equations, when you have the different signs, we add to eliminate. When you have the same signs, we subtract to eliminate. Okay? So this will give me a 0 plus 12G minus 3G. We get what? 9G is equal to, when I add 3A1 plus 12A1, I'll get 15A1 plus 12A2. This is equation start.
Okay.
Now, it's okay, even if we do a number for the whole lesson, no problem. As long as people have got how to solve very well. Now, when I divide by 3, I'll get 3G is equal to 5A1 plus 4A2. This is our star theory. Okay? Now, we are now safe. Remember, G is 9.8, so it's a number. The unknowns we have are A1 and A2, which is the same as star 1. So star 1 is G is equal to 2A2 plus A1. This is star 1. Now let me ask, which method do you want me to use? Do you want me to use elimination again, or you want me to use substitution?
Elimination.
Elimination again. But you know, it is also good to make the choice. Reason being, when you look at this A1, it is easy to make it a subject. Okay? Then if you're to call for elimination, it means you multiply star by 4 to eliminate A1, or by 5, and this one by 2. So the best I can see is substitution. Since I've already showed you elimination, using substitution, A1 is equal to G minus 2A2. Now get this A1 and boop, drop it there. What shall we have? 3G is equal to 5 brackets G minus 2A2. Wahab, are we fine? Plus 4A2. Magala, are we fine?
Yes.
Wahab, are you okay? And the
Yes,
rest,
teacher.
please. The rest also, please, if you have a concern, raise it. This is mechanics. Sometimes it's not easy going. So you have to do a lot of consultation, a lot of asking, in case there's something you're missing out. All right? Now, can we simplify? Open brackets. You'll get 3G is equal to 5G minus 10A2 plus 4A2. When the 5 crosses over, you get a negative 2G is equal to negative 6A2. Finally, my A2 is equal to 1/3 of a G meters per second squared. When they tell you to leave G in your answer, that's the answer. If they don't tell you so, you say 1/3 times 9.8. It will give us what? 3.6.
2.267.
Huh?
0.2667.
Are you sure?
6 recurring.
Yes.
Okay.
0.26 recurring.
Like that. Huh? Now, let us look at this one further. Get this A2. Substitute here where you made the subject. We shall have A1 is equal to G minus 2 times 1/3 G. This will give me 3G minus 2G over 3. The answer is also equal to 1/3 G. Are you seeing that?
Yes.
Now, let us go for the tensions. Because they ask for the accelerations, they ask for the tensions. So come back where you can use this one. T1 minus 3G is equal to 3A1. T1 minus 3G is equal to 3 times 1/3 G. T1 is equal to 4 what? 4G newtons, which is 4 times 9.8, which will give me 4 times 9.8 is what?
39.2
newtons. Then consequently, I can get T2. T2 is 1/2 T1. From here, remember this equation? So it will give me T1 is equal to 2G newtons, which is equal to 19.6 newtons. Now, there is a very sensitive question which can come here. This sensitive question is, the question can come saying, those are accelerations of the pulleys, yeah, as they rotate. But they can ask you, find the acceleration of the 2 kilogram mass. The acceleration of the 2 kilogram mass is not the acceleration of the pulley. The acceleration of the 2 kg mass. Imelda, what is the acceleration of the 2 kg mass? Imelda, the acceleration of the 2 kg mass we saw as what in the diagram? Imelda. Narika Imelda. You sound dumb. Sylvia Tishime. Sylvia, what is the acceleration of the 2 kilogram mass? According to the diagram, in terms of A's.
It's 2.
Eh?
It's 2, Van.
It's what?
It's A2 minus A1.
Lovely. It is A2
minus A1.
A1, which will be, it will give us what? A third G minus a third G. Because they are the same, the answer is 0. It means the 2 kilogram mass is not moving in this situation. Then can I have the other person who? Can I have Nicole Mbabas? Your hand was up. Do you have a concern? Nicole Mbabas.
No, I just wanted to answer.
Okay, then answer me. What is the acceleration?
The
of
one
the
for 2 kilograms.
Give me for the 6 kilogram.
A2 plus A1.
6 kgs is A2 plus A1. Is the acceleration of 6 kgs. And this will be a third G plus a third G is equal to 2 over 3 G meters per second square. Which is the same as what? 6.5774. No. 3.
Recurring.
Like that, not so?
Not 4. So it does not.
Eh?
3.
How about the 7? 7 times
So
2 is 4. 3
the 4 is
recurring.
not today.
How about a 3?
Yes.
Okay. So that is our answer. So these kinds of Atwood machines require such a presentation. But like I've showed you, one of the key important parts is the methods of solving simultaneously. Yeah? The other lady had an example. This is the end of the definitions. Next lesson, what I will do, I'll solve some of those mixed examples. They can mix this kind of Atwood, like the other question the first person asked when I had just started the lesson, or they can mix it with the other one, which has average acceleration. They can mix it with an inclined plane. So I will get one suicide number, which has a mixture of all those. And then we also try that number out in our next lesson. So unless someone has a question. If no question, please download. Start downloading, but I'm going to leave you with one number. Yes, please.
If a pulley is not moving, can it have acceleration?
Which one?
I'm just asking.
If the pulley is not moving.
Okay, if any pulley
is not moving,
yeah,
does it have acceleration? Okay. Now, it depends. If it is this one, A1, which is not moving, it will show you that A1 is 0. If it is A, this light pulley, that is not moving, it will show you that A2 is 0. It will not be rotating. Just like this question has showed us that the 2 kilogram mass was actually not in motion because its acceleration was what? 0. But, no, it was in motion. Sorry. Have you heard what I've said? The 2 kilogram mass, the acceleration is 0. But the acceleration being 0 does not necessarily mean that it is not moving. Because some of the conditions for acceleration to be 0 are, 1, a body is moving with a uniform velocity, or a body can be moving with a constant velocity, or a body can be moving with maximum what? Velocity. So these 2 kgs could have been at that instant moving with maximum or constant or uniform velocity. So likewise, even these pulleys, if they are rotating and they rotate with a uniform velocity, then their accelerations become what? 0. So madam, it is possible for the acceleration of the pulleys to be what? 0. That is if and only if they are either not moving or they are moving with a uniform what? Velocity. Have I answered you rightly?
Yes, thank you.
Time. Any other question, guys? Please never hesitate to ask. Some of those other sections I'm not teaching in math or physics. If you have a challenge, please don't hesitate to send me the number in my inbox and I take a look at your number. Someone sent me a number on differentiation. Please remind me, because there are so many people who ask me, remind me today so that I can answer your question. The same applies to someone also who was sent a number. Please remind me. Sometimes I am so busy that I end up missing out on your chats which are asking me questions. Just keep pestering me. At the end of the day, I'll answer you. Just keep reminding me. Don't give up. It's not that I'm not failing to answer you, but sometimes I'll get taken up. And since now we are back to school. So keep reminding me, I'll always answer your questions. We have 6 minutes to economics, but before that, I want to draw the other diagram. Or let me send a screenshot. I had forgotten. I'm sending it on the group, the number. Okay? Send the number on the group as soon as now.
Even in Google Class.
Yeah, the Google Class still has issues. We are finalizing it. I guess this weekend. We shall be through by next week, so no worries. We shall upload numbers. I've sent the trial number on the WhatsApp group. Please try it out. Someone has asked me My WhatsApp number is 07828555674. And those of us who are new guys and you missed some of these topics, please always remind me so that we can send you the videos and tutorials of the earlier lessons so that you catch up. Otherwise, you might find some of these things very hard, very complicated, very boring, just because you are not asking for some of these things. So always look out for those items and we send them to you. Okay. Okay.